All right, so this video is going to start on page 26 of your packet. So we're going to talk about interference and standing waves. So what happens when two waves meet while they travel through the same medium? What effect will the meeting of the waves have upon the appearance of the medium? And will the two waves bounce off each other upon meeting, or will they pass through? Okay, so we're going to talk about wave interference occurs when two waves meet while traveling along the same medium. The interference of the waves causes the medium to take on a shape from the total effect of two individual waves within the medium. Okay, the task of determining the shape of the resultant wave from any interference requires the use of superposition. So that's a new term there. So the principle of superposition is stated as follows. When two waves interfere, the resulting displacement of the medium at any location is the sum of the displacements of the individual waves at the same location. Okay, so constructive interference. So this is like almost like constructive criticism. Anything constructive means to make things better or bigger. Okay, so we're going to see about what it looks like when two of the same types of waves hit each other. So if we have, like here, we have wave A and wave B. Okay, so wave A, wave B. Wave A is going to the right, wave B is going to the left. Okay, so that is before they hit each other. Okay, so what happens is once they do hit each other, okay, if they're both positives, they're going to make that wave even bigger. So their amplitude's going to actually combine to make a bigger wave. So this would be like A plus B. Okay, and then once they pass through each other, they're going to go right back to the same. So now we've got our waves have gone back to where they were before. So B is going this way still, and A is going this way still. Okay, so if you've ever been wakeboarding before, there's a thing called a double up. Okay, where basically you do, it's kind of like a lazy donut where you're going to come back around and you want your wave to hit the original waves you already sent up. So when those waves hit each other, if you time it right, okay, you make the wave twice as high, which will launch you even higher. Okay, so that's a concept that some of y'all might know. Now, constructive interference is observed at any location where the two interfering waves are displaced upward, but it's also observed downward. So that means if A and B were flipped over, okay, it would be like combining both of them just in the down part. Okay, so same concept. Okay, but up and down doesn't make any difference. If both the waves were down and they met in the middle, then the amplitude would be bigger downward. Okay, and then they would just move on just like they did in the diagram above. Okay, so now destructive interference, that is when you have something that's like a positive and a negative meeting each other. Okay, so like here we're going to have our A wave coming along, and we'll say our B wave is on the down. Okay, so A is going to the right, B is going to the left. Okay, so this is before they hit. Now, once they do hit, you have a positive and a negative. What's going to happen is if they're the same amplitude, like if one was a +5 and one was a -5, they would just cancel out. So the wave would just disappear. So in that moment, when they meet in the middle, A and B just disappear, okay, because they cancel each other out. Now, once they're done, okay, they're still going to move along. Oops, let me redo that. B is still going to move along to the left, and A is still going to move along to the right. Okay, so the wave just didn't disappear completely. They just canceled each other out when they met, and then they go back to where they were in the middle. I'm sorry, back to where they were after they meet in the middle. All right, so now let's actually put some numbers on it. So we have two interfering waves do not need to have equal amplitudes in opposite directions. So that means it doesn't have to be an equal up and down wave. You can still have destructive interference or constructive, okay? But we'll actually use numeric values for this. So let's try diagram 1. We'll say we have a wave going along. We'll say this wave is -4. I know it doesn't look like it. And this wave is a 6. Okay, so 6 is going to the left. -4 is going to the right. Now, when they meet, you're going to combine those. So when they meet in the middle, 6 and a -4 are going to make a 2. Okay, so it's still going to be a little bit of a wave. Okay, but 6 is going to be a lot smaller now because that -4 kind of cancel out some of that. But then once they pass through each other, you're still going to have the 6 moving to the left, and you're going to have the -4 moving to the right. Okay, so that was 1. So let's try another one. So we have come along. We have a 3 moving along. Now I'll actually make this one look a little more real. You have a -7 going to the left, and you have a 3 going to the right. Now once they meet, you're going to combine those values. So now you actually have a bigger negative value. So when they meet in the middle, 3 and -7 are going to make a -4. Okay, so you're just combining those. And then once they go through each other, -7 is right back to -7. And then 3 is right back to 3. Okay, so they're not canceling each other out completely in this case. Now they could if one was like a +5 or a -5. They cancel each other out and it would just be a straight line. Okay, but this is just showing how that destructive interference occurs when they meet, and then they just go back to normal once they've moved on. So now you can have both constructive and deconstructive interference. Now this one's kind of hard to draw. I know the key, I think, has better pictures than I can make. So it just shows that usually waves aren't, you have multiple waves going on. It's not clean. Okay, so you can have like a normal wave 1 second, and then you'll have some destructive interference or some constructive interference. It just depends on where they line up. Okay, so that's usually what waves kind of look like. It's not very just clean cancellations or constructive or destructive. Okay, so the key's got better pictures than I can draw on that one. Now, as far as nodes and antinodes, okay, so when multiple wave pulses meet, nodes and antinodes will be created. A node occurs during the interference where the wave position has amplitude of 0. Key thing there. A node has no displacement within the medium, means it's just a flat. That's where it has 0 amplitude. Okay, an antinode, okay, anti means opposite of node, has a maximum displacement during the constructive interference. This is a point on the interfered wave that has a maximum amplitude. Now, this is what's called a standing wave right here, is when you have a wave coming along. We'll just do a normal wave. Okay, a standing wave is basically when you have another wave coming back the opposite direction that has the exact same amplitude and exact same frequency and exact same wavelength. So basically it's just going to look like the opposite. So this is what a standing wave looks like. Okay, now a node is what we talked about the first part. A node is when it meets in the middle. Okay, right there. So nodes are in the middle. I know mine's not the best drawing ever. Okay, but where they meet in the middle where there's 0 amplitude. Okay, so that would be a node. Okay, so if I were to ask you how many nodes are in this standing wave, you would just count 1, 2, 3, 4, 5. There are 5 nodes. Okay, now an antinode is the top or the bottom. Okay, so an antinode would be up here. Okay, and if you were to ask how many antinodes there would be, it'd be 1, 2, 3, 4, 5. Okay, so that's just knowing the terminology that a node is where it has 0 amplitude and an antinode is where it has the maximum amplitude. Okay, true, false. Identify the following statements as being either true or false. When two pulses meet up with each other while moving through the same medium, they have a tendency to bounce off each other and return back. That is false, because we just talked about that, is the waves are just going to keep going through each other. Okay, now whether they're constructive or destructive when they meet in the middle, okay, that's up to the waves, but they're just going to keep going through each other like nothing happened. Okay, 2, constructive interference occurs when a crest meets up with another crest at a given location on a medium. So yep, I have a positive with a positive. That is going to be constructive interference. Okay, destructive would be if you had like a crest and a trough meeting, okay, like a top and a bottom meeting. Okay, but constructive is when it's either a top and a top, or a crest and a crest, or a trough and a trough, which is a bottom and a bottom. Okay, 3, I'm sorry, that was true. 3, destructive interference occurs when a pulse with an amplitude of 5 units interferes with a pulse with an amplitude of -5 units. Yep. So I have a +5 and a -5, so those are going to cancel each other out, so that is going to be destructive. 4, destructive interference occurs when a trough meets up with another trough at a given location along the medium. That is false, okay? That would still be constructive. Okay, whether it's a top or a bottom meeting, Okay, that is constructive interference. Number 5, if a pulse with an amplitude of +5 units interferes with a pulse with an amplitude of +3 units, the resulting amplitude of the medium will be +4 units. Well, one, that makes zero sense mathematically at all, even if it was destructive. But if I have a +5 and a +3, 5 plus 3 is going to give me an 8. Okay, so that is going to be a wrong answer there, and that would be constructive. Okay, so that is false. Number 6, if a pulse with an amplitude of +5 unit interferes with a pulse of an amplitude of -3 units, neither constructive or destructive interference occurs. Well, this is definitely going to be destructive. Okay, because of +5 and a -3. 7, two sound waves could never interfere in such a manner as to cancel out each other and produce silence. This is actually, two sound waves could never interfere in such a manner as to cancel each other out and produce silence. So this is going to be false right here, because this is basically how noise canceling headphones work. Okay, so basically it's basically matching a frequency or a wave and stuff to cancel out the incoming sound waves. Okay, so that'll end the video for this one. We'll start on page 30 on the next one.